Hello again. Okay, let's look at an introduction to producer behavior. In fact, we can call this an intro to the dominant CEO, dominant CEO behavior, right? Okay. Item number 1, we'll look at definitions and assumptions. Item 2, we'll look at the short run, production in the short run. And item 3, just very briefly, we have the long run production. Now, under definitions and assumption, we'll look at what production means, what a production function is, and some assumptions. So let's do that first. Okay, yeah, that's our little econ person, right? Rolling down the river with a little fish there. I thought to make this a bit more interesting for my crowd on YouTube and for my students. Anyway, what is production? With production, we take some inputs, right? We use inputs to create output. So inputs to create just any output? No, we want to create outputs that our consumers will value and will be willing to buy, right? Output which consumers value and are willing to buy. Okay, so then what is a production function? With a production function, we use some math, right? So we use a mathematical relationship to describe the quantity of output that we make from some inputs. So use a mathematical relationship to describe the quantity of output to make from inputs. Now, how do we write that out? Well, there are multiple ways to write this, but really our output is put into some function. Our output is derived from some function of inputs. You see? All right. So we've been able to describe or define production, and we've been able to use a mathematical relationship to describe the quantity of output that we can make from inputs. We need some assumptions though. Some assumptions that concern how this mathematical relationship will be written out. How many outputs are we interested in? Well, 1. Right, so here we have one output as one of our assumptions. Now, what about this decision process? Right, are we now going to think about what inputs we want and what kind of output we are going to make? No, that decision process is done. So we are done thinking about what we want. Basically, we know what we want, right? We are done thinking about what we want. What we want in this production process. Okay. Now, what is the behavior? What is the ideal behavior of the firm? Like I said, the producer we are thinking about is a dominant CEO. And the CEO is a profit maximizer. Or at the very least, if the CEO is the CEO of an NGO, a non-profit organization, then they are a cost minimizer. You see, so the firm must maximize profit or minimize costs. So the firm must be a profit maximizer A cost minimizer. Okay, so how many inputs are we thinking about? Well, from the mathematical equation I have written out up here, you see 2. So there are 2 inputs, one labor, good, and the other one, yes, physical capital, physical capital, physical capital, not financial capital, physical capital. There's a difference. Physical capital, example, tools, equipment, factory, assembly lines, data centers, etc. Okay, so tools, big tools, small tools, hand tools, machinery, etc. Okay, all right. What is the time horizon of all of this? Well, there is the short run and there is the long run. So that is the assumption 5. What is happening in the short run to our inputs? Well, in the short run, we fix capital, and we allow labor to vary. We vary labor. In the long run, all our factors of production can vary. All factors of production can vary. Okay. So if we use more input, what does that get us? Well, more input will just make us more output. Cool. So we keep using inputs whilst one other input is fixed. So for example, I can fix capital and keep increasing labor. Well, there are diminishing returns to labor while capital is fixed. And there are diminishing returns to capital whilst labor is fixed. Do you see? So diminishing returns to labor as capital is fixed, or vice versa. Now, what about our input prices? What are input prices? Prices that we pay to get labor to work for us, or prices that we pay to get some capital, right? What's happening to those prices? Well, input prices are fixed. They do not change. They are fixed. Do you see? So these are some important assumptions to make whilst we are writing out production functions or trying to describe a production process. Okay, now here's another thing. Can our firm fund its own ventures? Yes, the firm can absolutely fund its own ventures or fund itself. Now, the firm is not constrained by a budget. The firm is not constrained by a budget. So, what is the firm constrained by? The firm is constrained by the output level to produce. That's what the firm is constrained by. Okay, so what did we just work on? We worked on the first leg of today's discussion about our dominant CEO's behavior, definitions and assumption. Definitions around or definitions of the production process and the production function, and the assumptions that we are making in order to build this production function. The second thing that we'll talk about is production in the short run. When we think about production in the short run, well, what's happening in the short run? We assume that in our short run, capital is fixed, labor is allowed to vary. So what are we looking at under short run production? We are trying to observe or examine the relationship between the output that we produce and the factor of production that we allow to vary in the short run. In the short run, we vary labor. So the interaction between output and labor, that's what we are going to observe in this second leg of our discussion. So what will we look at? Again, short run, we are fixing capital and allowing labor to vary. So we will observe the relationship between labor, which is varying in the short run, and the total output, also known as total product, that will be produced by the firm. So we'll look at total product, and we'll look at the slope of that. So when I say total product Q, basically that's the production function. Q equals a function, right? Q equals some function of our inputs. And so when I draw that production function, we are looking at total product. Total product as we change labor. Okay, we'll also look at the slope of that function. The slope of the production function. That is known as marginal product. And then we'll look at the average product. And then we'll look at the relationship between marginal product and average product when your production function is completely concave versus when the production function is S-shaped. You see, so we're going to work on all that soon. And then I'll take you through some math, and I will introduce the Cobb-Douglas production function. And then we'll look at some real data of some of these ideas. Right, so I do have quite a bit packed here for you. So our little person is making its way, or her or his way, down the river. And where is our person now? Well, almost halfway through, right? So we are almost there. Okay. So let's start off by looking at this production function. Q equals K to the power 0.5, L to the power 0.5. We need to find the marginal product of labor if K is fixed in the short run at K bar equal 4. Okay, so very quickly, and then I'll jump into the other things. Very quickly, let's calculate this. Right, the square root of 4 is 2. So this is 2 L to the power 0.5. That is our production function. And so, what is marginal product? Well, the marginal product is a derivative. The marginal product is the change in total product or quantity or output, change in output divided by change in labor. And so, well, it will be my 2 times the half times L to the power 0.5 minus 1. And so, well, that is 1 divided by L to the power 0.5, right? So that is our marginal product of labor. So I'm working on our left-hand side here. Are there diminishing returns to labor? Just look at your marginal product of labor. It's 1 divided by L to the half. As we add more labor, what will happen to the marginal product of labor? Right? Think of this whole ratio. As I increase the denominator of the ratio, what happens to the entire value? It plummets, it falls. So yes, as we add more labor, marginal product of labor falls. And how do we know this? Well, I know this from experience, but I also know this from the math up there. Now, I can graph this for us. Before I do that, let's answer what average product of labor is. Now, average product of labor, let's get my eraser out to clean this up and we go back. Average product of labor, I know what my Q is. My Q is 2L to the power 0.5. Now, I divide that by L. And so this is 2, right, divided by L to the power 0.5. Now, take a minute to see why that is. So I have my marginal product of labor and I have my average product of labor. You can see that, well, they're not really the same. Average product looks like twice that of marginal product of labor. Exactly. So here, what is the relationship between marginal product of labor and average product? Average product of labor looks to be larger than marginal product of labor. Yeah. So when we draw this, now, for those of you who have some graphing tool, right, you can plug this in and try to graph it. When you graph it, what would it look like? And I'm trying to change my colors here. Let's draw our total product in black. When I draw the total product, it's going to look concave like this. And so let's call that the production function. Oops. Let's put that on the second line, production function. Right, we have drawn the production function here. And so what about the marginal product? Well, from our calculation, it seems the average product is here is larger than the marginal product, right? What does that mean and what would that look like? Just following the colors here, I'm going to draw my marginal product. My marginal product will look like this. Will look something like this. To look something like this. That's my marginal product of labor, right? And it seems my average product in red is going to be above that, right? The average product is going to be above that average product of labor. There's a very interesting relationship that the marginal product and the average product have. The marginal product acts like a magnet. Whenever the marginal product is below the average product, it will drag it down. So here is an interesting example to think about, right? For those of my students who are listening right now, the marginal product is like your semester GPA, right? The marginal product is like, let me write that in blue so that the colors are synced up. It's like your semester per semester GPA. Well, okay, per semester GPA. And the average product is like your cumulative or your overall or cumulative GPA. You see, so per semester, if you really didn't do well that one semester, you will notice the effect it has on your overall GPA. It drags it down, right? But the semester you did great. Let's say you had straight A's. Then your average or your overall GPA went up. Do you notice that? Okay. All right. Yep. So this is what it looks like. This is what it looks like. So before I move on to the next thing, let's think about marginal product for a minute and what it means. Marginal product of labor is such that as we hire more workers, the additional output each additional worker brings is marginal product. And we are saying that as we hire more workers, if you have a concave production function like we have here in the graph you're looking at, as we hire more workers, each additional worker will bring less and less and less and less additional output. You see? Okay, so what is average product then? Average product is you take all the outputs and you divide by the quantity of labor that you have. Now, the next thing is unrelated to the math above, but I need you to see that this is a different looking production function. This is the S-shaped production function that I had mentioned earlier. S-shaped, S, like the letter S. It's shaped like the letter S. S-shaped production function. What is happening here? Well, you can see that we have output increasing quickly. Output increases at an increasing rate. Right, so let's get to these objects out of the way. That way I can make my point a little better. How about green? There is an inflection point here. Now, those who remember some math, right? There is some inflection point here, and I'm going to drag this green line all the way down, and you'll see why later. There is some inflection point here on the graph above, right? Before that inflection point, we see a convex shape such that output is increasing at an increasing rate right here. After the inflection point, so after the vertical green dots that I have drawn, after that we notice that output is increasing but at a decreasing rate. You see, it's that rate of change that we are interested in. That's marginal product of labor. Again, we have labor on the x-axis of the top graph and total output or total product or Q on the y-axis of the top graph. And what do we notice? We notice that as we increase labor up to the green line, up to the green vertical line, output increases at a faster rate or increases at an increasing rate, after which output increases at a decreasing rate. It's that rate we are capturing. Now, for those of you who go, how does she know that? Some calculus. Some calculus. So, all right, what does this mean for marginal product? Well, this means that from the beginning, and I'll try to draw this in blue. Marginal product is in blue, right? From the beginning up to the vertical green line on the bottom graph, we will see that our marginal product increases and hits a maximum. Now, does marginal product ever get to zero? Yes. How do I know that? Well, on the top graph, we notice that our production function hits a flat point right here where I am drawing the yellow vertical dotted line. And so, on the bottom graph, marginal product in blue will fall, and hit a zero right there. And then marginal product will become negative. How do I know that? Because on the top graph, total product or the production function starts to nosedive, right? The production function starts to nosedive. So that has helped me draw my marginal product, that there is an increase in portion of the marginal product, and then there's a decrease in portion of the marginal product, and then there's a portion of the marginal product that's negative. Okay, great. What about average product? Like I told you, the marginal product is or behaves like a magnet, right? The marginal product will pull the average product up when it is above it, or drag it down when it is below it. Now, the difference is up here, we had a completely different setup. We had a fully concave production function, right? So let me write that down for us. This was a concave production function. And so our marginal product of labor fell throughout and was below our average product of labor. And you can see that from the math, the average product was bigger anyway. Okay, I will stop the video here. I'm trying to get shorter videos, so I'll stop the video here and come back and continue. All right.